Let's look at some examples of the standard I/O file functions. This is average.c. It is a working program. I have completed it. I completed it because it actually takes quite a while to write these programs, and I didn't want to waste your time while I wrote it. So what I'll do is I'll just walk you through it and I'll show you the important and relevant parts to it. Let's have a look. Okay, here's our main. Here is a variable that I'm going to use to store the file handle when I get it. And what else have we got? Oh, we've got one of those little add exits. We're going to pause, which is just what you saw before. Just ask them to press enter. Okay. Now, here's the important part. Firstly, we try and open the file. What file? What's this program actually going to do? Well, it's going to ask the user for a series of numbers, and it's going to write all those numbers into a file. It's going to calculate the average, and it's going to write that to the file as well, and it's going to put a little bit of header and footer information in there as well. So we're going to get something of a report. It's like we're going to write a report about this particular program's operation. So we need to create the file or write to the file. So we use the W option because we're writing. We're not reading, we're creating a file, so we're writing to it. And what is the name of the file? Well, we get that from fname. And where's fname? Well, fname is just this. We're going to put it at the top of the C drive. Now, notice that I need 2 backslashes. I can't just put backslash like that because in C programming, backslash is a special character. So I have to use 2 backslashes because if I don't, then the compiler will read that as \t, which is the tab character, followed by est. So I've got to put the 2 of those in there. That's quite important. Don't forget to do that when you're using file names. Anyway, now very importantly, you need to actually test. You absolutely always have to do this. It is well, it's not a rule, but it's a very, very strong guideline. If you don't test, then you might be trying to manipulate a file that you never actually succeeded in opening. If fopen fails, it will give you back a value of null. Null means I didn't successfully open the file for you. And it does a little clever thing then. It sets a global variable called erno. That's this little variable here. Now this is not mine. I didn't create erno. Erno is a system-wide global variable that is set in the standard C library functions. And any time a function like fopen fails, then erno gets set. It contains an error number like 6 or 12 or 27 or 91. And that error number is used to describe why the program failed, why that function failed. So what you can then do is you can then feed that into an array of strings. That sys_erlist is an array of strings. We're going to print out that string right here. And following this, so sys_erlist is another global variable. This time it's an array of strings. Erno is just an integer, whereas sys_erlist is an array of strings. So you can use that to determine, you can actually print out an error message, a descriptive error message, as to why the program didn't do what you wanted it to do, why we weren't able to open the file for writing. So this will say, I could not open the file, and there will be the file's name, and then this will be the reason why I could not open it. So that's a handy little thing to do. And then we'll exit the program because there's nothing else for us to do. Okay, very nice. Well, it'll also do that. At the time of exit, it will do that. Now, let's assume that we got past that, so we successfully opened the file. We're going to try and write to it. I'm going to do an fprintf, and I'm going to use that file pointer, fptr, to write to it, the file handle. So, this is going to be the very first line, or 2 lines, of my report. Now, fprintf is designed in such a way that if it returns less than 0, that means it could not write to the file. Here's another standard C library function called perr. It stands for print error. And all it does is it prints out these words, and then it prints space and a dash and a space, and then it prints out the reason, exactly like that. And that's all it does. It's very simple, except it writes it to, just like I've done, it writes it to standard error, which is where all error messages should go, as separate from regular messages. A regular message might be this one, program ended, press enter. That's not an error message. That is a legitimate real message, and so it goes to standard output. This one is going to go to standard error, and so is this one. P error always writes to standard error. Then I have to close the file, and then I'm going to exit. It's good to keep in mind to always close a file if you've got one open just before you exit a program. I know the operating system will do it for you, but it's a good habit to get into anyway. Anyway, so what we've done is we've successfully written one line of text out to our file, and we've tested to see whether we could do that. Let's keep going. Let's write the next line of text to our file. I'm going to write this. I'm going to write created on, and then I'm going to put out a string. That string, and it's going to come from this other standard library function that I've never mentioned to you before called ctime. Ctime prints out the current time. C does not stand for current. C just stands for, well, the language C, I'm guessing. The function ctime will return to you a string which represents the current time, or an ASCII representation, a string representation of the time that you pass it. So you pass it the time, and you get the time, the current time, from the operating system by calling the function called time. I know it's a complicated way of doing it. You've got to set that into a variable, and then you've got to pass in the address of that variable. I know that's a lot to remember, but if you just copy and paste this bit of code every time you need to access the time, then you won't have any trouble. If you want to learn more about that, look in the standard C library function header called time.h, and you'll discover all the time functions that are available to you. I just wanted to show you that you could do that. Finally, we're going to put out a little header saying the numbers are, and then we're going to read in some numbers from the keyboard. Mind you, this printf here and this scanf is just regular one from the keyboard and the screen. Now, they might say 0, and if they say 0, we can't compute an average because we'll be trying to divide by 0 and we'll probably crash the program. So, if they say 0, then we say we put the words there are no numbers to average, and we don't put that on the screen, we put that in the file. That will be what appears in the file. Then we close the file, then we exit the program, because that's all there is to do. Now if we get past that, then they haven't entered 0, they've entered some other number. So we can go into a loop, and this is what we can do inside the loop. We can ask them to enter the number from the keyboard, and notice that's a regular printf, a normal one, so that will appear on the screen, and that is a scanf from the keyboard. Accumulate the number, and finally we'll do an fprintf this time, and we're going to write that out to the file. We're going to write out the current index, like 1, 2, 3, 4, 5. We're going to have many numbers, so we'll just put the number of which one we're up to, and then we'll put the actual number that they typed in from the keyboard. And then a final message and close the file. We'll give them the average, which is that, and we'll put that into the file as well, and then we'll close the file, and that'll be it. Return 0, which of course means no error. So what's going to happen here, it's all very nice. We can see what's going to happen is this program, if it's successful, is going to create a file for us. It's going to create a file on my hard disk, and the file is going to be called, where is it? Here we are at the top, test123.txt on my C drive. So let's go and see if there is one of those files there right now, just to prove that I'm not cheating. Here's my C drive, and there's no file called test123.txt. So let's now run the program. Okay, compile, no errors, run. How many numbers do you want to average? How about 3 numbers? Please press enter number 1. That'll be 4, 5, and let's say 8. Program ended. Press enter. Okay. I wonder what happened. Let's go and have a look at my C drive again. Aha! We have a file called test123.txt. Let's see what's in it. Let's open that up. Okay, and that's exactly what I hoped we would get. There's that first line of text that I said we were going to create. There's the current date and time. That's what we got back from the ctime function. And there's the 3 numbers, and there's the average. Okay, so the program seems to be working beautifully. What I'll do now is I'll open up another file that's going to read in that data again and show it on the screen. I've shown you now some text-based writing to a file. I'm now going to show you some text-based reading from a file. This is average2.c, which just reads in that file that I just created. In other words, we're going to have the same test123 I've created my file pointer this time as a global, a static global. We'll see why in a second. Okay. We're going to take advantage of the @exit function. And @exit, we're going to close the file. Also, we're going to pause. Open the file for reading this time. Notice the little R there. There's no B, so it's not the binary, it's a text file. And we simply say could not open. Now, we don't have to say %s. See if you can figure out why. Notice there's no comma after the second double quotes there. Oh, interesting. @exit, close the file. That's nice. So we'll run this automatically anytime the program exits for whatever reason. So now we print out this on the screen. This will come out on the screen. The lines in the file name are as follows. Read all the lines. Now, this is how fgetS works. When fgetS can no longer read any lines from the file, it returns a value of null. So we can keep reading lines from the file until we get back a value of null. We're going to read them into buffer. And buffer is 300 characters long, just to make sure it's absolutely long enough to hold any line that we might find in the file. And then we print out that buffer here to the screen. We write out the buffer to the screen and we prefix it by just the line number. That's all I'm going to do. That's what I'm going to do. Is the count there is just going to keep track of how many lines are in the file. So this will be the line number. So I'll put the line number and then I'll put the line from the file itself. And then another one of those big lines across the page, and then tell them how many lines there were in the file. So let's run that. And run. Okay, look at that. The lines in that file are as follows. And there's that file that we just had a look at a second ago. And that's, yeah, there's a bunch of line numbers down there. There were 12 lines in the file, and that looks about right. Program ended, press enter. Okay. Now I know I went through that very quickly, but I suggest that you open up this file, average2.c in the chapter 16 folder, and examine it at your leisure to look at all those lines again. Finally, we're going to look at reading and writing binary data, not just text data, but binary data to and from a file. We're going to use our employee example. Let's have a look at that. This is employee.c in the same folder. And it's not text files at all, it's binary files. And let's have a look. We're going to now use a file called emp.dat, which is short for employee.dat. So here's our employee structure, got a type def. All of this is exactly the same as before. Here's a function to read an employee from the keyboard. So we just ask the user to enter the name, we read it in from the keyboard, very standard stuff. Print one out to the screen. Okay, so we've got a couple little functions to do that. I can make that a static void, can't I? Because it doesn't have a return value, and I can do the same with this one. Static void. Okay, and let's move on. There's a pause. Well, that can be static as well, because no file other than this needs to access it. And here's my main. Let's make sure main has got a return 0 on the end. It does. Okay, let's have a look at the workings of main. Now I'm going to open a file for writing, but it's going to be a binary file. See the B there? The B means binary. And firstly, I'm going to put out the error message. If I can't do it, could not open the file. And just do that. Now, moving on, ask the user on the screen how many employee details they'd like to enter, and read that number. And then go into a loop and ask them to read that number of employees and write those details out to a file using fwrite. Now, using it, you haven't seen fwrite before. We're going to write them out one at a time. So we pass it the address of the employee that we're going to write out. It must be a pointer. You can't just say pass it the structure. You've got to pass it the address of the structure. That's vitally important. Then you say how big is the memory area that you're trying to write out, and how many of them are there. Well, I'm wanting to write out one employee, so we use size of the employee and 1. And if that is less than 0, then we couldn't write to the file. In fact, if it's less than 1, we couldn't write to the file. That's right, isn't it? Because fwrite will give us back the value of 1 if it successfully wrote that to the file. Then I close the file. Then I open the file again. and this time for reading. So what I'm going to do is I'm going to write all the details out to the file, and then I'm going to read them all back in again and print them out on the screen. So we try and do a read this time, and again we do an error message if it failed. And while this is a loop here, while that condition is true, then we're going to keep reading from the file. And the I, the variable I, is just going to count how many there are. So we'll start with an I equals 0, and we'll count up each time. So I'll just reiterate, I know that looks quite complex, but while we continue to read one employee from the file, then do the following. Print a line across the screen, print out a little header for that, and then print out that particular employee details. Again, I pass in the address of our E variable, which is going to be a place where they can read the employee data into. And then I say how big that area of memory is. I say, well, it's one employee exactly. And then I tell the user how many records were successfully written and then read again from the file, and then close the file a second time. So I know we're doing quite a lot of things here, and the output of the program is probably going to be quite simple. All we're going to see on the screen is we're going to read a bunch of details from the user, and then we're going to print them out again. But what will actually be happening is that all those details will be written out to a file, and then they'll be read in again from the same file. So if we get the details printed out on the screen, it will prove to us that our reading and writing routines were bug-free. Let's try that. Let's compile and run. How many employees? Well, 2 is probably enough. I don't want to waste everyone's time. We won't waste time coming up with clever employee names. 23 and 23. Employee 2, we'll call that number B, and that'll be 56, 56. And let's see what we get. These values of employee 1. They all look correct. 23, 23. Employee 2 is B, 56, 56. 2 records were written and read. Program ended, press enter. Okay, so that's pretty impressive. Our fread and our fwrite were all working there. Now, for the final proof, let's go and have a look at the contents of that file. That's on my C drive again. Let's go and have a look at that. Okay, there's emp.dat. Well, let's open up emp.dat in Notepad and see what it looks like. Now, remember, this is a binary file. It is not a text file, so I'm not expecting to see any meaningful data when I open it up in Notepad, but it's worth a look anyway. Okay, here it is, and as you would expect, it is pretty meaningless data, but you can see there's the person's name and their address. Now, they were 23 years old, but you're not going to see the 23 there anywhere because it's a binary version of 23, it's not an ASCII version of 23. And then there's the second record with all the B's and so forth. Now, it's a binary file, so you're not really going to see any useful data there. But I just wanted to look at it just in case. So what you can take away from this particular exercise is the fact that it is quite possible to, to write out one structure or an array of structures if you want to just write them out as a block out to a binary file. And then again, you can read them back in again exactly the same way. So it's a really useful way to store data that you've got in your program. So we've seen text files being written to and then read, and we've seen binary files being written to and then read. So that is a pretty good synopsis of